Okay, so these are the notes on calorimetry. You should have a worksheet to go with that, so make sure that you're filling that out as you go along. The first thing we're going to do in trying to understand what calorimetry is break it down into its roots. So the first thing is the word calorie. You might have heard that before when talking about food and whatnot. This is actually slightly different than the type of calorie that's in your food, but it's the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Knowing that the specific heat of water is 4.184 joules per gram degree Celsius, you can see how we get that 1 calorie is 4.184 joules. Okay, so calorie is a unit of energy, joules is a unit of energy. That's the conversion factor between the two. The other thing we have here then is a different kind of calorie. This is spelled with a big C instead of a little c, and it actually means kilocalorie, or 1,000 of those calories, those little c calories. And this is what's shown on food labels. So if you're eating something and it says that it's 100 calories, it means 100 kilocalories, or enough to raise 1 gram of water by 100,000 degrees Celsius. So you can actually see that there's quite a lot of energy in the food that we eat, just based on that fact. The next part of the word is this ending. It ends in the suffix metry, which means measurement of something. So put it together, calorimetry, you get the measurement of heat movement through a system. So to undergo calorimetry, we use this device. It's called a calorimeter. You can see here it's got a thermometer in it. It's also got, usually it's made of styrofoam cups just because that's the cheap kind. You could make one of these for yourself. The styrofoam cups insulate the heat from getting into or out of what you're working with. So basically, the way that it works is you're going to drop some sort of substance down here in the calorimeter, and it should have a liquid inside. Usually it's water. And that water or that liquid inside will change temperature, and based on the temperature change that occurs there, you'll be able to figure out how much energy has been added to the water because you know its specific heat. So you can calculate that. There's this more fancy type of calorimeter. You can go ahead and look at all of its parts, but basically the purpose of this is to really keep everything in. This is called a bomb calorimeter. What it does is it burns things that you put inside, so you can see there it has an ignition coil. And this is what we use to figure out how many calories are in things like food. So we just put them inside a crucible and we ignite them in the presence of oxygen and see how much energy they give off, and that is the amount of energy that's contained within the food. Another important thing here with calorimetry is that the energy that's lost from the system, this would be what you're putting inside of the calorimeter, equals the energy that's gained to the surroundings, okay? That the surroundings in this case normally would be water or whatever liquid that you have in there. And then if you think about it, the reason for this is if you have it as an insulated vessel, the energy that's going out of what you put in there has to go into the water. That follows the law of conservation of energy. Okay, so when you're doing a calorimetry calculation, it involves 3 typical steps. The first step, you calculate Q of the surroundings, usually the water. So you'll do an MC delta T problem on the water. Then if you remember that the Q lost by whatever you're putting in there is the same as that Q gained by the water, you know that this the Q lost by whatever you're putting in there should be MC delta T for the water. It should be the same thing. And so then you can set up an MC delta T for whatever you're putting in the calorimeter, and then calculate for the missing variable. And so just to summarize actually how that kind of looks, you get this equation that says negative MC delta T, the heat lost by the system, equals MC delta T for the surroundings. And this is, again, just the law of conservation of energy. And you'll have on that side there with the MC delta T of the surroundings, usually some water has been heated up by some number of degrees Celsius, and you can find energy there that equals the energy that was given by your system, the energy that was lost by your system. Then we have basically here 6 variables, and you'll be given 5 of them, and then you have to solve for the other one.